A Stuart 504 boiler water gauge problem. A closer look at the sizes of commercial water gauge glass tubing and silicone rubber O-rings. This is my collection of small pieces of glass tubing for use in water gauges of various sizes. Most of these are made from something called borosilicate glass or Pyrex glass, and in case you're wondering, the gauge glasses with the red and white paint are of the type that make the water level more visible. I had a problem with the 504 boiler and I featured it in my series How to Build a Stuart Model Steam Plant. In actual fact, there were two problems in this area, both of them to do with the water gauge. Initially, the glass tubing supplied with the water gauge from Stuart Models did not even fit in the holes in the water gauge. I substituted a piece of glass from my box of pieces of glass. This glass tubing fitted into the holes okay, but it didn't seal very well with the O-rings. It's never a good idea to over-tighten the nuts on a water gauge, because this will happen. They need to be just tight enough to seal the O-rings. But the pair of black O-rings with this water gauge were not good at all. And by having to over-tighten the nuts, you can see what's happened. The glass broke in the bottom fitting. The first thing I'm doing is checking that the fitting is central by putting a piece of glass tubing in and rotating it, and as you can clearly see, everything's okay in that department. Some people use a piece of steel bar to centralise the fittings, but I prefer to use the actual piece of glass tubing that I'm going to fit. At this stage I was using various different pieces of glass tubing from my box, and suddenly it occurred to me that they weren't all the same size. I decided to check the variations of the sizes of glass. And for this, I'm using my digital caliper which eats batteries, but at the moment I've put a new one in. Normally glass tubing is sold in metric sizes, and this one is 5mm. The diameter of this piece is supposed to be 6mm. And this is another supposedly 5mm diameter glass. Alright, I'm being picky and I know it's not a lot. But the diameters of some of these pieces of glass did vary considerably, like this piece that was very close to being a tight fit. And to make matters worse, here are the original O-rings that came with the kit from Stuart Models. These would be okay for 5mm glass, but I'm going to use a size smaller. I'm going to use this type of silicone O-ring. These are steam grade and they are available from Blackgates Engineering. This clip shows the difference between the piece of glass I'm going to use and the original piece of glass that I fitted to the water gauge. Cutting the glass is simple. Normally I use this tool, which is a rotary glass cutter, but you can use a needle file and scratch the glass and then it will snap at that point. I've shown this process many times in quite a few videos. This piece of water gauge glass is a bit unusual. It's got quite a thick wall. And dimensionally I think it is imperial. As you can see, it's a good bit less than 5mm. When you break these pieces of glass they are quite sharp, so it's a good idea to give the end of them just a bit of a rub on some wet or dry sandpaper. That way there's less chance of cutting your fingers when you push the O-ring onto the glass. I have a bit of a problem here though. The O-ring that I'm using is too thick. Depending on the O-ring size that you're using, this can be successful. I've put the O-ring inside the nut first. But now the glass tube will not fit in the O-ring, so obviously these O-rings are a bit too thick. I always keep a good stock of O-rings. I have a large box full, and I had a look in there and found some smaller ones. The ones on the right are just a little bit smaller than the ones on the left. These smaller O-rings are quite a snug fit around the piece of glass, but small enough to go into the nuts. As once again I fit the O-ring to the glass tube, you can see why it's a good idea to remove the sharp edge, for two reasons. One is you don't want to cut your finger, and you don't want to damage the O-ring. I had to do a small amount of pushing and pulling with the nut, but eventually, with the top O-ring and nut engaged with the thread, it's now time to repeat the process with the lower nut and O-ring. And there's not a drop of blood in sight. I haven't tightened the top nut because I need the glass to slide down easily. I've found that once you start to engage the bottom nut, it's a good idea to support the top one and rotate it in the opposite direction. just to stop it unscrewing. Common sense, I know, but I thought I'd mention it. In this part of the clip, I'm supporting the glass between my forefinger and thumb to stop it rotating. In no time at all, both of the nuts are finger tight, and really this should be sufficient. I would normally tighten the nuts to seal the water gauge glass with compressed air and some water in the boiler. But in this clip I've just shown how little I need to turn the nuts. After refitting the top cap, the water gauge is complete. And hopefully this time it won't leak and the glass won't break. Famous last words, and on that note, that's it for this episode. With a last look at my box of water gauge glasses, all I need to do now is perform another steam test on the boiler, which I'm going to do very shortly. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.